Next are some physical properties of these hydrocarbons. So hydrocarbons we read before as well are non-polar molecules. So they will be not soluble in water, but soluble in other non-polar organic solvents. They usually have low melting and boiling points as the bonds between them can be easily broken. They are generally less dense than water. So when we try to mix them in water, they will float at the surface or at the top. And as the length of these hydrocarbons increase, the melting and boiling point will increase and their density will also increase. And there is this special type of forces present between their atoms known as the van der Waals forces, also known as the London dispersion force. So this is a special type of bonding that is present between these molecules. So the same point that was there in the last slide, that melting and boiling points of these hydrocarbons increase with the molecular weight within a homologous series. So it's just being shown in a table format. Methane we can see is the smallest of these and has the smallest molecular weight, 16 grams per mole, has got the lowest melting point and the boiling point, whereas the ecosane, which is the largest here with 282 molecular weight, has got comparatively high melting and the boiling point. Next are physical properties of isomers. So an important point to note that is that isomers with the same molecular formula can have different physical properties. So in the table are shown a few compounds and all of them have the same molecular formula, that is C6H14. But we can see that the boiling points and the melting points of all of these isomers are different from each other. As a general rule about the physical properties of isomers, basically when the branching of these isomers increase, their melting point and their boiling point decreases. So here we have got a pentane here on the right side with a boiling point of 36, whereas 2,2-dimethyl propane on the left, which has got plenty of branches in it, and its boiling point is 10. So as the branching increases, the boiling point decreases. That is the rule for the isomers physical properties. And next is carbon classification. So carbon atoms are classified according to the number of other carbon atoms to which they are attached. So a primary carbon is a carbon atom which is attached with only one other carbon atom. Secondary carbon, it will be attached with two other carbon atoms, whereas tertiary will be attached with three other carbon atoms. Whereas the classification of the hydrogen atoms is mainly dependent on the type of the carbon atom to which it is attached with. So any hydrogen that is attached with the primary carbon will be considered as a primary hydrogen. And the one attached with secondary carbon, as shown here, will be considered a secondary hydrogen, and the one attached with tertiary carbon will be called a tertiary hydrogen. So it simply depends on which type of carbon atom it is attached with. Next are a few examples about the classification of the carbon atoms that we saw in the previous slide. So the question is, classify each of these carbon atoms as primary, secondary, tertiary, or quaternary. So quaternary was not there in the last slide. Quaternary carbon is any carbon that is attached with four different carbon atoms. So we have got this first example, CH3, CH2, CH3, CH2, CH3 is the formula. So one way of finding out which carbon atom can be classified as what is simply check the number of hydrogen atoms that are attached with it. So if you look carefully at the first carbon, it is attached with three hydrogens, that is why CH3. So when it is attached with 3 hydrogens, it automatically means that it will only be bonded with 1 carbon, and the carbon that is attached with one other carbon is known as the primary carbon. So this first one will be the primary carbon. The second one, again, if we check how many hydrogens are there, so it's attached with 2 hydrogens. It automatically means that it will be attached with 2 other carbons. So this one will be a secondary one, and the third one here is attached with no other hydrogen. We can see it's a simple C, and there is no other hydrogen attached with it. So when it's not attached with any other hydrogen, it means that it is attached with 4 other carbons. So this is a quaternary carbon basically. So this way you can figure it out easily. Simply check the number of hydrogen atoms, and the remaining bonds will be with the carbon atom. So if it has one remaining bond which will be with the carbon, it's primary, and secondary, tertiary, quaternary, and so on. And this is one way of doing it. Let's check the solutions basically. So as I told you in the previous slide, so same is the case. CH3 here, 3 hydrogens means it's attached with one other carbon. This is CH2, so it will be a secondary carbon, and this one is a quaternary carbon because it does not have any hydrogens attached to it. For the linear structure, it is even simpler than that. Basically, we simply have to assume that there is a carbon here, and there is a straight line over this side, represented by, you can say, this blue one. So this is the one that it is making a bond with other carbons. So it has only got one bond. It means that it has to be the primary one. Whereas the second carbon, which is located here, now this one has got two lines, or two bonds, which will be with the carbon. So this one is a secondary one. Similarly, this one is also secondary. This one has 3 bonds which are with the carbon. So 1, 2, and 3. These bonds are representing the bonds with the carbon. So this carbon will be a tertiary carbon. So for the linear structure, it's simply you have to count the lines that are originating from that carbon, and that will correspond to the primary, secondary, tertiary, or the quaternary carbon. And next step is the nomenclature, or the naming. So there is an international organization known as the International Union of Pure and Applied Chemistry, shortened as IUPAC, which is responsible for the chemical names of any compounds. Now before learning the IUPAC rules for naming these alkanes, the names of structures of 8 alkyl groups must be learned. So these are some historical or some old names of these 8 alkyl groups, and they are accepted by IUPAC, and they are integrated into the modern naming system that is developed by this IUPAC. So we need to know what these alkyl groups are. An alkyl group is simply an alkane with one hydrogen atom removed from it. So we take out one hydrogen atom from an alkane, and it becomes the alkyl group. And it is named by simply taking the A and E at the end of the name of alkane out, and replacing it by YL. So methane is the smallest of the alkane, CH4. We take one hydrogen out, it becomes CH3, and the name of the alkyl group will be methyl group. So we have taken the A and E at the end of it out, and replaced it with IL to name it with the alkyl group. Next simplest alkane is the ethyl group, which are derived from ethane. So ethane is C2H6 basically, and if we take one hydrogen out of it, it will become C2H5, and it will be called the ethyl groups. Now the thing to remember is that all the six hydrogens are equivalent. So we can take any of these hydrogens out. It will they will all be the same. Doesn't matter which hydrogen do we take out. So we have taken the three different hydrogens out of it, and all the three structures are exactly the same. Basically, they will be called ethyl groups. Here is a table showing the names and formulas of the first five alkyl groups, and these you have to memorize. The CH3 group is known as the methyl group, which is derived from methane, ethyl group from ethane, propyl group from propane, butyl from butane, and pentyl from pentane, containing 1, 2, 3, 4, and 5 carbons respectively. Here are a couple of structure and names of branch chain alkyl groups. So these alkyl groups have got branches in them. So they've got some common name as well as the IUPAC name. So with these two carbons and a branch is what we call 1-methyl ethyl. So ethyl is representing the two carbons in the main chain, and 1-methyl is representing the branch. Common name is isopropyl. So propyl is basically for the three carbons in total. Whereas the lower one has got 4 carbons in total, so the common name is butyl, whereas IUPAC name is dimethyl ethyl. Next is a table for the main carbon chain length and the prefixes. So depending upon the number of carbons in the chain length, we've got the alkane name as we've already done. So with 1 carbon it is called methane, 2 carbon ethane, and so on. And the prefix we will take out the ane at the end of the alkane name, and we'll use the first word, that is meth for alkane, for the methane, eth for ethane, prop for propane, and so on. So the prefixes simply take out the ane at the end of the name of any alkane, and we get the prefix. So naming for the alkanes is continued here. So there are some general rules about naming these alkanes. And the first rule is that we have to determine the parent name of the alkane by selecting the longest continuous carbon chain in the formula. And the longest chain may be bend or twist, so it's most of the time it takes bends and twists. It's seldom horizontal, so it's almost never horizontal. Sometimes it can be, but it can be bent as well. So the rule is take the longest continuous chain of carbon. Doesn't matter whether it's bent or not. And any carbon group not part of these base chains will be called the branches. So it will have some branches or substituents, and the carbon groups are known as the alkyl group. So these branches will be our alkyl groups. So when we apply this rule number 1, which is find the longest chain in each molecule, the carbon chain we are talking about. So in the first diagram, the longest chain is going to start from this carbon, and it continues this way and ends up till here. So we have to count how many carbons are there. It turns out there are 8 carbons in this one. So the 8 carbon main chain will be called octane in this first one. And for the second one, the longest chain is this one, and it has got 7 carbons, so it will be called heptane. So rule number 2 is numbering these carbon atoms in the chain. So we have to follow the rule that numbering will start from the end, which has the branch closest to it, basically. So the chain starting from the end with the first branch. So if we look at this one, we have started numbering from this carbon. This was the main chain, basically going this way. So obviously there are 2 ways or 2 ends from which we can start, either this end or this end. So we will start numbering from the end which has the branch. So the first branch exists here, which is at carbon number 3. So this one is closest to the start point or the beginning. Whereas this one, if we start numbering from this end, this will be carbon 1, 2, 3 and 4th. So the branch will be at carbon number 4, and which will not follow the rule or the IUPAC rule number 2. So we will start off from this carbon, which is 1, 2, and because the branch point is at 3, so we'll start from this one, and this will be 1 to carbon 1, carbon 2, 3, 4, 5, 6, 7, and up till 8. The second one also has one branch in it, and the branch is closest to this carbon, basically starting point, not this one. Therefore we start numbering from this end, 1, 2, 3, 4, 5, 6, and 7. And the branch point is here at carbon number 3. Whereas if we start from the other end, the branch will be at carbon number 5, and that will not follow the rule. Now, if both the branches are equally from both ends, basically, as is the case here. So the first branch here is at carbon number 2, and if we start from the other end, it also has a branch at carbon number 2. So which end do we start in such a scenario is we look at the second branch. So the second branch is here, which is near this end, which we have actually numbered as 1. So we'll start off from this end rather than the other end. So in case both the branches are at the same point, we will have to look at the second branch. So rule number 3 is that we have to write the name of the branches before the name of the parent chain or the longest chain. So the branch or the substituent name will come in alphabetical order before the parent name, and the parent name will be the longest branch. Apart from that, we also have to indicate the position of the branch on the main chain, and that we will mention by naming the carbon number to which it is attached with. So if it is attached with the carbon number 2, we will write 2 alkyl if the name of the branch is alkyl, and so on. And if there are more than one branches available, then we will separate the numbers with a comma in it. So separate 2 or more numbers with commas. For example, we have 2 or 3 same branches, say alkyl group. One is present at carbon number 2, other is present at carbon 4. So we will simply write 2, 4 alkyl, and the numbers and the letters will be separated by the hyphens. And for halogens, we can shorten as F for fluoro, Cl for chloro, and Br for bromo, etc. So when the branch occurs more than once, we have to prefix its name with a di, tri, or tetra, depending upon how many times it exists, 2, 3, or 4 times. And then list the number of the carbon to which it occurs basically, and separate the numbers with the commas, as I mentioned in the previous slide as well. So 3,4-dimethyl means that this molecule has got 2 branches of the methyl group. One is present at carbon 3 and one is present at carbon number 4. So we write the position first with a hyphen, and then dimethyl. Di means 2. So it tells us that 2 methyl groups are attached. Similarly, 4,4,6-triethyl. This tells us that it has got 3 ethyl groups as branches attached to it. 2 are present at carbon 4, and 1 is present at carbon number 6. So here are a few examples in which we apply the rules that we just studied. So first up, whenever we have a molecule, we check what is the parent alkane, and that will be the longest chain in that molecule. So the parent alkane has got 5 carbons in it, so it is named as pentane. And next up is we see the branch point there, and the branch point here is this methyl group attached with carbon number 2, so the whole name will become 2-methyl pentane. So the substituent or the group comes first, that is methyl, even before that comes the position of that group, and in the end will come the name of the parent alkane. Similarly, more examples. So first up, this is the parent chain which has got 4 carbons in it. So it will be called butane. There are 2 groups or branches present. Both are methyl groups. So one at carbon 2 and one at carbon 3. This one will be termed as 2,3 dimethyl butane. And the next one again is a butane, but both of its branches are present at carbon 2, so it will be termed as 2,2-dimethyl butane. 2,2 is mentioning the position of the branches, di means 2, so 2 methyl groups are present, and the parent chain butane at the end of it. More examples. This is the parent chain which has got 7 carbons in it, so it's a heptane. And so here we write heptane at the end. There are 4 branches present in it, one at carbon 2, one at 3, one at 4, and one at 6. So 2, 3, 4, 6, and 4 branches are there. So tetramethyl, which is the branch point. And the numbering will start where the branches are the closest to that carbon atom. So another example, this time the parent chain has got 6 carbons in it. So this will be a hexane, and this is our substituent group attached at carbon number 3. So this will be termed as 3-methyl hexane. And be careful to choose the longest chain, always remember. So we have to go with the longest chain, and in this case the longest chain is this one. So the usual mistake that some people can do is go with the horizontal chain in this way. That will be not the longest chain. To remember, the chain can be bent or twisted, but it has to be the longest chain inside that molecule. Another example for ethyl 2-methyl hexane. So this is the parent chain hexane, and it has got a ethyl group at carbon number 4 and a methyl group at carbon number 2. Do remember, when we have different alkyl groups as the branches, the one that comes first in this case is ethyl. We have to mention them alphabetically. So because E comes before the M, therefore ethyl is named first and then the methyl group.